I, I thought you just said that I cannot apply, so I thought emerge. Solving some problem. Actually, finding inverse matrices take a lot of time. And to use the inverse, like if you want to solve this equation, then it firstly needed the matrix M is square, and simply we will consider the determinants is not 0, because if it's 0 then it will not invertible. So in this case we will get the solution M inverse B by multiplying M inverse to the left side of the both term. So I don't know what point you are complete. Yeah. Some property for how matrix can get inverse matrix or some others than that. Have something like this. So you mean if you have some large matrix, and it will divide up part of partition, and like these are all square matrix, and 1 times n1, and 2 times n2, and 3 times n3. In this sense, we want to find some inverse matrix of this large matrix, and really finding this partition is kind of decomposed to subspace. Yeah, maybe you need to. Yeah, if we learn this class to the final, we will learn the decomposition. It is until Christmas. We need 8 class, 8 times, and in our plan it's until 8th of December. 8th, the second Monday of December. So if you find this subspace of decomposition, then by finding the M1, M2, M3, of course it's inverse can be M1 inverse, M2 inverse, M3 inverse. Because if you calculate, if you're multiplying two matrix, then you only multiply it for each block. So if I understand what is your question, exactly example. No, no, yeah, I think I can give some. I can make some examples for about this. So yeah, I think from next class, or if we have extra time, let's deal with the problem that. Then okay, now let's back to the class. This chapter is change of basis. And we saw that basis always has the same number of elements for a vector space V. So that means if you have by using a basis, you will have coordinate map this map was, if you have a basis S1 S, we want to Vn for V is finite dimensional vector space over field F. I think in here we do not need to consider what field is, and so simply it is easy to understand that the field is just real number. So, and if we wrote a vector V in S as a tuple of the vector space F to the n, right? So then we might consider the vector is not really an element in F to the n. We just represented. We just express in an element of here. So it can be considered as a map, and the coordinate, that is the coordinate vector of V. Relative to S. Then this map from V, vector space V, to F to the n, and which is called a coordinate map, which is called coordinate map. from V to F to the N. And we expressed it as a column vector, like Vs is C1, C2, Cn. In this sense, we sometimes need to find what is efficient basis to calculate easily. Then in this sense, we need change of basis. That is the problem. That is the problem for change of basis. So I mean, if you consider, you already have one coordinate map, and if it is hard, then you will change the basis. That means you want to find a new coordinate map. Then we need to some sense of map or operation of V on F to the N. And so we want to work as a same from this map and from this map. So to be like that, if you send I will say C1, C2. If you let me change F1, F2. Send an element in V from F1. It will in F to the N, and by sending this map G2, it will in also F to the N. Then it is mapped from this to this, and we work as the same for this map F2. So finally we want to get F2 completion G1. V is also same to the result of first one. This means just the diagram is commute. So finding this coordinate change to calculate easily means just finding some operator between V, because if you give this, then to make a commute diagram, this map will give how G2 work. So I think the coordinate change is quite difficult notion, so I will give some examples today. Firstly, let's see that beta is U1, U2, and beta prime is U1 prime, U2 prime, are basis for basis for a vector space V with dimension 2. It is the dimension 2 vector space V. Then maybe you can write a vectors u1 and u2 as a basis for u1 prime and u2 prime, like u1 beta. If I write is a, c, it is just coordinate, because if you have a vector v, u1 is a vector in v. We can denote by using a basis beta prime or beta prime. It will give a coordinate in beta prime basis, and let u2 beta prime would be b, d in a basis beta prime. That is, u1 is a u1 prime plus c u2 prime, because u1 is written as a beta prime elements. So a u1 prime plus c u2 prime is u1. This means this equation, and the second equation means b u1 prime plus d u2 prime, and then we have linear system. This linear system will give a augmented matrix I miswrote b. Oh wait, u1 is a u1 prime c u2 prime. u2 is b u1 prime d u2 prime. Then b c d u1 prime u2 prime. Okay. If it, as an example, if it in this example, I think it is easy to give up two bases on a real vector space. If you have beta 1 is standard basis, and beta 2 is another basis, I will give 1, 1, 1, 0. It will be a basis for R32, right? And then we wrote the vectors in the basis beta as a u1, u2, then u1 beta prime can be written of a linear combination of beta prime, because u1 is an element in R22, and since beta prime is a basis for R22, so by calculating linear combination like C1, 1, 1, C2, 1, 0 will be 1, 0. By calculating this equation, I think to make easy to calculate, let's consider 0, 1. Then, in this sense, if C1 is 1 and C2 is minus 1, then this equation will satisfy it. So this vector is u1 and another two vector is u1 prime, u2 prime. So this means, let me write the abbreviation first. u1 is 1 u1 prime plus minus 1 u2 prime. 1 u1 prime minus 1 u2 prime is equal to u1, and also we can calculate the coordinate for a vector u2. C1 1,1 plus C2 0,1 is equal to 0,1. Then in this sense, if you bring C1 is equal to 0 and C2 is equal to 1, then you will get this equation. This means 0 u1 prime plus 1 u2 prime would be u2. It is the expression of each vector in another basis were expressed by another basis. This is old one, this is u1, new basis. So we wrote this as a coordinate vector like this form by using in here S. If I wrote the basis, all of the basis as like that, then it is a linear combination. C1 V1 plus C2 V2 plus Cn Vn is equal to V. It is the expression of column vector. So if you write the vector u1 under the basis beta prime, then the coordinate is 1 and minus 1, 1 and minus 1, and in the same way, u2's beta 2 expression is 0 and 1. Can you understand? A little. We will combine all notions from the previous chapter. We in the last semester we defined some coordinate vectors and some linear combination and how to solve the linear equation, linear system. So we will use it with under two bases. So if you have a basis beta, then it will have vector v1 to vn is a basis for v, and as I said before, we can find another basis. Basis is not unique, so you can find another basis, but today we proved that the number of vectors in each basis is same. So it will have n vectors, and another basis will have n vectors as well. Then we will focus on what is the first vector in all the basis. This is old one. This is a new one. And then we want to know what is V1 as a coordinate relative to beta prime U basis. It will be written as a coefficient